I actually already did a bit of work. I was very... I couldn't... I couldn't make it slime that this debug stuff wasn't working. I was trying to fix it. I first converted it to a while loop, which is more efficient, since like recursive function calls are way slower, since they have to like push stuff to params, they have to like unwind stuff. I also have a worse stack limit. Also, just store a lot of redundant state that we don't need. Since here we are just like traversing the tree, it's not like we are actually like traversing multiple branches, paths at once anyway, so there's no need for redundant state at all. When it's faster. I was trying to make it work, but it doesn't work. It's my logic is has some holes, and what I found is an interval tree, and I have not really read it, but it gave me some ideas. Should probably read it, but I don't know. I had the idea that instead of splitting, I would actually just insert a node. So I have this bind for my mouse forward that mutes me, but it also is used by the browser to go forward and by many other apps. Really fucking annoying. My mouse doesn't have explicit binds. Probably needs to get some software for that. External software. So maybe Extrafy M42 drivers. Did they maybe release some new drivers that I don't know about? That would be neat. Say this one. So give support page or something. I don't really know. Extrafy support. I also had like a weird double click recently where it would left click when I released the left mouse button, which was really fucking annoying. But I used like the condensed air or whatever, and like in a spray or whatever, and it seemed to have fixed it, thankfully. And I have bad luck for mice. This mice is pretty neat, honestly, but if it doesn't work, if it breaks, then XD. Yeah, I don't even know where to go on their website. Whatever, it's not that important. Interval trees are what's important. And let's think about this. What is the search API for this, anyways? Because I just need to find one bind, one like thing, right? Defines a point, so. Oh, I see. So it like stores a high value. Hmm. I'm not bothering to read the entirety of this, but There's also attempts to store every node, which maybe I don't need. Huh. Hmm. So this is very interesting. Very interesting. Center point. Why would we need a center point? Hmm. Oh, I don't really even know why that would be useful. Maybe I should like start. Maybe I should like watch an interval tree video. That would probably click way easier. But let's try to read this. My mind really gets lost when you introduce any kind of like weird notation. Like this is fairly simple, but still, I will just lose myself. This is so stupid. This is like such an overkill. Hmm. 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 So if we have an interval that is just next to each other, then we can just sort it like this, right? And when they don't overlap and they're on the left, then we can sort like that. And then if we have something that does overlap, like for example, like this, or this, or this, right? Kind of different cases for it, I feel like. This one could just simply be like, I guess could just be like this, right? Straight up pointers, but those like weird ones. How do we store them? I could try storing them in above, right? So have it here and here. Or rather here and here, like this. But does that introduce problems? I don't even think so. It does definitely make the algorithm harder to write because it probably requires some recursion. Uh, but then if we query, like, let's say this byte, we know that we only need to look here. But if we query this byte, we only need to look here. So I think that could work. Right? Those anyways are kinda easy anyways because they are uh, like they are all subsets or smaller, right? And then we could have something like this that is this big. And in this case we probably would want to insert it before this one, I feel like. The way I was doing this one is instead of like storing additional pointers, I would insert. It's like I would split this to like new set of things, right? That's my idea before. Instead of having additional list, I would split it. And then actually, this case I didn't handle at all, right? Was not assuming it even can happen, and also I wasn't assuming this case can happen. And the split code was very complicated. I tried to make this like work for the contains, but it doesn't really work. I think I'll try to say overlaps as one, and now what I will say is static pull debug node overlaps, right? Debug node A, debug node B, right? I also say debug node contains left on left on right. Now we'll make those inlines. The reason I'm making those fast is probably I probably want like in the final version. I will just remove this split thing. Right. And now this will actually make the result under stable. That's kind of neat. And what I will say is return B by n is smaller than A by its turn, right? And this one would be I wonder I want to make this B. Do I want A on the left of B? I guess so. So that actually would be inverse. Bind N equals B bind start. Then here we would say that A start is greater than B bind end. Okay. It contains would be A bind start. Oh my god, so many weird cases to handle. And this is just like error report. And I need to write this. Holy fuck, so annoying. So we'll say the bind start A is here, and then B bind end is A bind end. So that means A contains B. And now overlap. Well, option left would be return. So you'd say that the byte start is smaller than the B byte start, and A byte end is smaller than B byte end. Okay. Smaller or equal. And we'll do the same on the other thing. It's just instead we just have this, right? Hmm. Does that make sense? I don't know. Let's try that. Overlaps. Hmm. Oh, 1 sec. Well, I'm back. But this is not very fun. I want to be done with it. And this solution doesn't even work because I'd have to start it in both. And I'm not gonna use the interval tree. It's too complicated for what I need. And I need something simple. Yeah. So Don't know. I don't know what to do. Is the nice thing is if we'd have like a contain font. I mean, sure, let's just have this, right? And I guess this means we have to make this, we have to make this, a recursive function. So say left. Actually, this was wrong because it should be not left like this. So XD, I was just wrong here. That's probably why it was broken. At least in the revised version. But what I had was not sufficient anyways, so it's fine. And what I would say is if we contain, so compiler node new node, right? Sorry, no compiler. Okay, yeah, so having redundant pointers, it's fine, I guess. So it means that one node could... that's bad, because it means we have to do... have to pass this like that. Let's remove all of this, actually. Maybe not this. This might be useful. Usually say debug analog, debug node, compiler, new node. There's an interesting case when the new node contains the known. And then what we can get is an overlap. Overlap on left, right node. So let's say the new node overlaps on the left. This overlaps on the right. Now we just say on the left, on right. Right. It should be unreachable. Okay. And now this should probably just be here. So if this happens, we allocate the node. I'll just keep a copy of it for the sake of this, and we'll say contains equals all node as n for none. Right. In this case, we would just say actually we would prepend. Makes sense. Prepending. And what we need to do is just say compiler. Actually, to make this faster, I will use a pointer. New node. Let's say debug alloc node. New node. New node. Compiler new node like this. Debug node. Alloc. Alloc debug node. And we'll just have a clone here. New node. I have to yet again replace. Okay, new node. Okay, this is just it. Right? Return contains. So in this case, we just do it on the right. In this case, we do it on the left. In this case, we do it on the left, but yeah, what I will do here is I will also copy a clone debug node, right? New node, other new node. This will be our clone, and this will be in node contains. Okay. And actually, to make this a bit more sensible, is I will have a static inline bool debug node overlaps. I know, it doesn't make any sense. I think I wrote those correctly. I hope so, at least. Okay, so basically, if we have an overlap plus on left, that should do it. And now when we want to find, as we say, yeah, and in this case, we would say if node dot contains, we would just say node equals node contains. Continue, right? Right. Okay. So the search is still fairly simple. Does it work? No, we get stuck somewhere. Hmm. So maybe what I do is actually so what I would say is They probably just say node contains equals this, right? Say debug node old contains, right? Old node is something you can just move straight up here, right? And now here old contains would be node contains. Node contains. And now here is where we would say old contains contains equals old contains, right? That way we don't have recursion for containing. Oh. See how it works. Very interesting. One thing that I found we should do is when we have this thing, we should say define can't divide by 0, right? And we would say number only, and we would say number equals this and break, right? And here I would just say can't divide by 0 and also not have that semicolon. Can't divide by 0 b, and that's what I'm looking at. Right. Just say this like that. Yeah, I expected a semicolon not to break, right? Now the same thing I can do for float. And now the advantage of that is that they can clone it for modular, which also has to be 0 protected, right? Can divide slash modular. Okay. Okay, so what is the Booker JMC? Guess it's just crap. One thing I wanted to do, maybe not now, but I wanted to move Kairos stuff to Kairos folder and rename it from AI to Kai. I can't wait. Huh. So anytime we say debug node, so anytime we add debug node add, right? So I would log printf adding node. File name function new node line new node line start new node line end, right? I'll say is this, 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 right? Maybe be like that, and I need to use string format for strings. Okay. I also need a new line. Okay, yeah, I completely busted it. already know what it is. It's because this shouldn't be in function, it should be in declare function. Should do it like this. Statement. Like this, and that means that I can move this here. It was after, it was before byte start actually, and this can stay there, and we'll move it here. This is for call stack. Okay, and now we actually get something more sensible. It still says the wrong line number. I don't know why that is. Because the division here. Maybe my original code was just fine, I don't know. It was very messy. My problematic line is line 32. This is line 24. Oh, I think I know what it is. It's this comment here. No. It's not that comment. Comments are counted correctly. It's good to know. That's what I thought was happening, but for a second I thought it's actually broken, and it isn't. And honestly, this is a detail, but I think it should be tabulated like this. Or maybe it shouldn't be tabulated, maybe it should be like a manual amount of... No, tab looks fine, probably, although 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's do 10 spaces actually. 2, 6, 8, 10. That makes it exactly in line, but I probably want 2 more spaces. 12 spaces. Maybe 14 spaces. What looks the best? Goodbye. I think I would just use tabulator for simplicity. Whatever. Not that important. What I want to see now is if our bind... Yeah, we don't like line 32, actually. It's kind of annoying. Also, this pretending I do is incorrect, I think. Holy fuck, this is so annoying. I knew this would happen. I knew doing this runtime erroring would be a disaster. Just like everything that left on my list is painful to do. But let's see. Problem with this cloning shit is that it actually you kind of require a lot of cloning in pathological cases. So don't exactly know what to do about that. We don't seem to be generating anything for line 33, by the way. I don't know why. It's probable that the line is actually +1. I think that's even how it's done. So I'll say that. Okay. Huh. Already what this should do is this. I was causing problems before. Pretty sure that we're starting overflows. Oh no, that's actually an infinite loop for some reason. So look at the process memory. What the fuck is that? It's super pathological. Eventually we have run out of memory. That's interesting. Oh yeah, because arenas are capped at 40 gigs. Interesting. I wonder how that happens though. Oh, actually, I know what it is. Those should be first. Yeah, that fixes it completely. Okay. Because those actually don't say. Those actually don't mention that the byte. So it should also mention standard byte Also requires an overlap check like this, right? See how many times do we actually clown? Seems to be almost every time. It's pretty bad. And it only seems to be happening once, and that part is not that bad. Yeah, Phantom works. Phantom works. I'd rather actually have those as names because it takes me time to parse math expressions, and seeing this is more, it gives you more of an idea what actually happens, although obviously that might not always. This might be wrong, by the way, because do binary search trees actually always insert a delete? I don't know how people usually use that. I'm not gonna lie, I have never actually needed a binary search tree. I use like a heap, but fuck you. Insertion. Yeah, it does do it in leaf nodes, so that's what I find. And the case of container, yeah, might be different. Where did my original binary tree work? Um, we'll say very complicated. Let's say progress from stream 15 May 2023. Overcomplicated fix. Overcomplicated data structure for debug nodes. As they'll say, and I'll try is removing the overlaps and the contains thing. And just always saying that removing all of this crap, removing cloning. Okay, sorry. I think I do need cloning though. Yeah. There's one thing that I need to keep. And now what I would say is so now if new node byte start is smaller than node byte start, right? Move oops, right? And here's where I would say debug node insert component. I'll say move to goes through, right? Now if new node find end. So now if move we would say new node equals component already clone debug node component new node. And now you need a strategy for when something's like if we have an overlap, we probably want to do something, right? Say result equals 0, say result equals this, right? And we say return 0, and now if result, we say this. From result. So if there is a result, we say this. And if there isn't, we would say return debug. Something like that. Just say done. If there isn't a result, we just printf overlap not handled. Like this. Right, as a problem. I guess what I will return is the road node. For now. And there's one overlap that's not handled. 2, 3, 4. There's a few. Do we care is the question. Also, this add should be different because it should actually be. Should be called add. It should be from. Maybe. Seems good enough. What do we do for overlap though, is the question. Do we... So this is for when we contain a node, right? So I think that means we just reintroduce the contains, pointer contains, right? And we just debug insert contains, and we'll just do the same thing here. Actually, if there's no result, we know for a file we have not done that. And now all this does is we say if node has a contains, then we say node equals node contains. Continue. So this basically means that instead of having nothing, we just have. So basically, this would mean that we would prefer the smallest possible range, which is fine. I think there's minimal cloning involved for when a range is bigger. I also don't know what the structure of this is because, like, the most pathological thing that can happen with like a binary tree is when it like only goes one side, right? Then you actually get no search benefits because you would always have to hop this way and you would never save time. The perfect thing is where it's balanced. So where you just have something like this, right? Because then you always cut off the half when you go one way, right? And you say go here, you cut off this, and you know we're here, right? That's super efficient. Otherwise, we have to like hop, which is really bad. Now the question is, how does this work? Obviously, in this case, we also just have like this like redundancy thing where you can have something at the bottom, and then it could either have something bottom here or here, right? That's fine. Don't really mind that. Yeah, that's actually fairly efficient. I like this. So we only store like really what it does is, oh my god. What we do is one node. It has like some range, right? And then the right just says if you need something, if you need to move this here, right? If you need to. So it doesn't actually care if this sign is. I mean, it's fine because then we just binary tree in anyways. So basically what I'm saying here is that it doesn't care where this position is. But then since the next node does, technically it can just go right, which would mean like, oh, I want to move this side. So basically left checks compares against the left border and right compares against the right border. And if something is inside, we go down. So this data structure, I think, is perfect for what they need. It's simpler. It's faster. Let's see if it's broken, though. It's not. It's perfectly working. Epic. So I can now print that. Can now go here and say runtime errors are actually done. And now what this allows us to do is say we have like a recursive runaway, right? Which calls the runaway, right? Then we call it here. This is Stack Overflow, obviously, right? Oh, this doesn't crash the game. I don't know what it does, but it does something silly. Maybe it's just turbo slow? Question mark? That's so fucking weird, honestly. That looks like we have something very broken. Oh. Oh. Yeah. Need to make this something bigger. I'll make it IU16. This is overflowing, so that's a funny bug. We found it. And now what we can say is that we can see where it was actually called from, right? There's a big call style because it called a lot of things. But we have runtime errors. That's fucking epic, honestly. We have a stuck trace. And one, that's it. I think. That's 1 hour of a stream. It was an impromptu session that I started by just digging around. I wish I have streamed my initial progress, but yeah, we have good runtime errors, and I think they're pretty efficient. Let's see what it takes to. Ooh, so we'll print. See how many use does this print. So how quick is the find? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hops. Not too bad. And one thing I would prefer to do, if possible, is making this. Can't believe this is still a while through. Technically it isn't. Oh, this can technically have issue, create issues. I'll actually just remove that because technically that would like move the range. It's made on 29. It is. Okay. So this while true. Yes, technically doing nothing right now, but I would want it to do something. I would want it to say. I don't think I can do much about that. Okay, that's the stack thing. So we have multiple potential paths here. So maybe all I need to do is say, so let's say this, right? If new node and the other thing, so we'll say, actually I'll say both on left and on right. On left, on right. I'll say if on left and on right, it's actually more performant if we do that, funnily enough. And we know there are ones. So I guess I will use that as something I learned yesterday actually when I was reading that performance book. And now if we are on left and on right, that's when we would say that's when we would clone this. That's when we would use recursion, right? But otherwise we would just set the node pointer to node right. And we would continue right node pointer. Oh, yeah, here. Right, and otherwise this is just that. And in the case of this, it would be contains. Contains. And a nice thing is I can just say this because we always continue here. Right? Technically doesn't need to continue, but there's something broken about this. Right, so here we are in the second thing, and the node pointer known. Oh, yeah, the thing that I forget to do is clone the node. So that's why we had recursion, because we wrote to something that should be written to. Yeah, it works. It's really good. Way better. So we only have recursion when we need to have two separate paths. And otherwise we use a while loop. So this is very, 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 very much more efficient. So we'll say and progress from stream 15 May 2023. Simple data structure for debug nodes. Okay. Really, really, really good. Okay, that's it for me today. I'm happy that this works. We actually have good error reporting for runtime errors. And yeah, I'll just read this book now. So that's about it. And I'll do other important things. And what I will do tomorrow is probably I don't want AI to actually work. I also would want UI, and I would also want game state optimizations. I think it's probably time to start integrating Kairos into AI. Just like we don't technically need structures yet. Enums are really good. What I should definitely integrate is like I should integrate the enum list of every unit. So we go to Notepad++. Is if in our dev file we have a unit named like Terran Maverick, right? I would want this to be a unit ID Terran Maverick internally, right? So I just want done. We'll add that tomorrow. Jesus, they have I don't even know how that's named. Probably hiccups, but it's actually shit. It's actually say it doesn't tell me. Yeah, hiccups. Hiccups and really annoying. Anyways, that's what I will do tomorrow. So the enums, and I will do. I think it's time to make a request queue. I was thinking I would have like, I would have a. So request would go into a queue. And it would be like 3 priority queues. It would be like urgent, normal, and like low priority stuff. Although I don't even know if low priority makes sense, because if everything is in normal queue by default, that probably means that oh no, that actually makes sense, because then with thing what you would do is you would do something like make very urgent one act, right? Make urgent one worker, make one production, and make low. It's probably make high, or maybe it's like make high. No, I think it should be right. And we would have something like this probably, or rather, production would be low, and army would be here probably. It's my thinking. Because you don't want to add production if you have empty army worker. Like, if you can't afford currently to make worker an army, you wouldn't want to add production. Actually, I feel like it would probably more like it would be something like this, right? Unit ID, worker queue. Pretty high. Actually, what's neat, you can just have a global that says unit ID worker, like Zerg small f, right? That would be a global, and then in main, let's say you would have something like this. Have worker lib. This is this, right? As would just be it's like an async while loop, basically. Maybe I should have a loop keyword for when we have no condition. Maybe it looks better. But we would say wait until, or wait, I don't know. say worker, say train time of worker ID, right? It's probably what we would have. Consider adding loop keyword, which is an always looping while loop, right? And maybe if unit count worker is greater than 30, we would say, wait, 1 second or something, right? And then we'd probably say like worker loop in here, right? And we could have like an army loop, probably. Army loop. It would just be priority medium. Have like priority very high, medium, low, and maybe also very low. I'll probably say like workers, right? It's just panic. Maybe workers, maybe here. Army. Panic defense, probably. High would be like tech, and very low would be production. Use for. This is probably what I would say. It's just like AI script.chi is what I would name it. And here I'd probably say while wait train time of unit be Maverick. And this could even be like make on loop. That would be unit ID int, right? Let's say like production ID and actually there's no point in saying production and ID and unit ID. We'll just say production. This production unit count unit, or rather just unit. This would be unit. My army is actually supposed to be low. It's supposed to be medium, right? So this is basically what I suspect the priority would probably want to be like. Although it is very much possible that you would want tech here actually. High, medium, low. I think that's actually even more sensible. I mean, it will take experimentation to figure this out, but I think this one is the most sensible. And then, like, as a default, so this is medium, right? And here I would say make on loop, we'll say unit ID, RX, unit ID Maverick, right? Say Terran Maverick, Terran Borax. This would actually be Terran Mason. Right, and we could also say, so this is like, okay, so, like this is sort of an example. I don't think this actually works because you would want fractional, like relative requests. So like unit, this is like attack add relative style, right? Because now if I would want a Cyprian here, right, Terran Cyprian, here we, since here we are requesting too many. Actually, what I'm thinking could do this is just have a fraction float, right? And we'll say fraction here. And we'll just say 07 Maverick, 03 Cyprian is what we would do, right? I would do it. Now, one thing is if we would want to terminate those, we currently don't have anything to do then. And that sucks. Right. But I definitely want to do implement make. It would be implement native function make. Would it be count and would it be unit and it would be priority and as well, right? And now we would have train time and it's just a unit ID. Which returns an int. And then as I should name this, use the same syntax that we normally use. Another thing is unit count. Unit. Fine. I'll just say none. And those would need to be to do native functions. I don't know. Still tells me that I have 2 columns here. Whatever, it's not important. And we'll say to do priority enum and to do unit ID enum. And we'll say unit ID Terran Maverick, right? Okay, I think that does it. We will need also something like consider armies and expansions. That's something we'll need to do. And I guess I'll also say towns and expansion. Because we don't know what we will do about towns either. And okay. That's the idea. So this, you can see how structured this is. You can implement the things you need very easily. So yeah. That's it for today. I will send in to Pronago and see what he says. And I'm going to read that book and other things. So yeah.